Good morning, Ananda. Myself, Dr. K. Arun Prasad, working as Assistant Professor in the Department of Mechanical Engineering, PSN College of Engineering and Technology. Today, we are going to discuss about a topic which was trending for past 1 or 2 decades, 3D printing technology. The topic which I chosen for the presentation is an overview of additive manufacturing technology. Actually, you people hear the word additive manufacturing technology for a period of time as a mechanical engineer. First basic, we need to know about what is additive manufacturing. Then we move to 3D printing. Actually, there are two types of manufacturing is there. Number one is substrate to manufacturing, then number two is additive manufacturing. Additive manufacturing is nothing but where we can manufacture the component or a product or a part by means of stacking the material by layer by layer. I hope you understood. That is called as additive. Substrate to manufacturing means where we have the complete substrate with us, we can remove the excess material, then we will got the final product. That is called substrate to manufacturing. All other manufacturings, for example, we are doing drilling operations, we are moving for planning, shaping, milling, all other manufacturing or come under substrate to manufacturing. But this additive manufacturing where we build the component by means of a layer by layer promotions, that is called additive manufacturing. The 3D printing is one of the technology where additive manufacturing is followed, okay, because where we can prepare the component using 3-dimensional analysis, where we can use X, Y, Z by means of length, breadth, depth. We can easily draw a diagram, as well as we also draw the diagram with the help of the softwares available. So this 3D printing technology is one of the emerging technology where people they are using this technology for producing of parts in various fields of engineering, especially in the area of automobile engineering, as well as in the area of electrical engineering, the small electrical components, as well as the small mechanical gadgets were manufacturing using this 3D printing technology. Already we know there are so many softwares are available where we need to draw the diagram, as well as we need to take the output with the help of SolidWorks or with the help of Pro-E or with the help of CATIA. We can draw the diagram, then we can do some analysis, then we move for the productions area. So similarly, same we can use same softwares what is available in the industry nowadays. We can use that software, then we can draw the diagram. Finally, we can get the output. So this is the flow where we people are doing the 3D printing, and output of the 3D printing is got through this process only. So this additive comparing the additive manufacturing and substrate to manufacturing, additive manufacturing, there is no material removal, there is no excess material removal, there is no wastage of material is there. In the side of substrate to manufacturing, there is waste is available in the form of chips. That is very difficult to recycle the chips for further processing of material, so it's very difficult. So the additive manufacturing is one of the successful manufacturing methodology where we people are having the output of the product without losing any of the excess material. We only took a required material for building the component. After the building the component is completed, where we can take the printed parts for the specific application. That is the difference. So how we can create the component, that is the next idea. Where we people are this screen shows the subtractive milling, where CNC milling is available, you people may know about. Then how we going to design this 3D printing. Normally 3D printing we doesn't require any specialized software, because in industrial side we have softwares from SolidWorks is there, CATIA is there, then ANSYS is there, then Creo Elements is there. We can then triplex CAM is also available. Once we need to draw, we can draw easily with this type of software. Then we can import this drawn file in the form of SLL format, .slt format. Once SLT format is completed, we can move for printing of the component. This is the way how we can design a 3D printed part before it going to be printed. This is the small introduction about our basics about our 3D printing technology. Then we need to see some of the possible issues are available in the 3D printing. So for example, overhang support structures we don't print. Then print direction we need to control. Then fill in halos objects is very difficult. Then material selection is difficult. Ray resolution is also difficult. Then price of the tool and the price of the material is also high. We won't implement these things in our normal subtractive manufacturing system. But this additive manufacturing system is all are very simple thing, because there is no pre-processing is required for the printed part, there is no post-processing is required for the printed part, and the time of printing it will the material itself it will converted into a complete part in the time of working. So there is no any specialized materials required for this. Then these are some of the technologies which are available in the 3D printing for application and components for automobile sector or electrical sector, what else. But these are very important things we need to know. These are the basic 3D printing technologies available. From my knowledge, around 200 or plus 3D printing technologies are available. But in the industrial sector as well as in the academic sector, these are some of the predominantly used 3D printing technologies are there. Some of them are fusion deposition modeling, stereolithography, then DLP 3D printing, then photopolymer using inkjet printers, then SLS, then plaster based 3D printing, then thermal base changes inkjet materials, lamination object manufacturing. These 6 to 7 technologies are one of the wider technologies which predominantly used in all the sectors for the producing of 3D printed parts. Before we are going enter into these topics, better we need to study the principle of each and every technology, because guys nowadays the principle is converted into the application. So before we enter into our manufacturing technology, I am just introduce the principle briefly, then you people easily understood the technology. So it's very easy, because technology is a process, is very easy one, but principle is a complicated one, where we have identified the principle, then we can implement the principle in the form of application. That application is our technology. Then number one is fusion deposition modeling, FDM. You people may hear this word as a mechanical engineer in several areas. This FDM, fusion deposition modeling, was developed in the earlier stages of night. Actually, the 3D printing technology was first introduced in Japan in the year 1911, where they can, without removing the material, they just start creating a material using layer by layer. They are using some heating envelope, they can heat the material, then they will just stick the material by layer, they can prepare a complete. That is the first 3D printed material which was introduced into the world. Then day by day the technology will develop after 1950s. We have so many methodologies will come under the foot of this 3D print to enhance the quality of the 3D printing technology. Now, this fusion deposition modeling was developed by Scott and Lisa in later 80s, but the trademark is gotten by some persons. Then we can use this fused filament fabrication is also another name for this fusion deposition modeling. Actually, fusion deposition modeling, we normally our 3D printing technology, you can see here there are 3 numbers are there. This is X direction, Y, Z. We can move as well as we can prepare the component in all three directions, or we can see the component, or we can edit the component in these all 3 directions, X, Y, Z. This is common terminology for all of the 3D printing technology. Okay, so this fusion deposition modeling, the basic is where we having a filament. Actually, the materials such as polypropylene, ABS, then some other polymers as well as nitrobutyl are some of the predominantly used the 3D printing material, where we can use these polymers by means of heat. We can just make them sticky, and we can start printed our components. So there is the simple logic behavior. Here we are having a filament pool, where filament pool we have different colors. Based on the colors we can select the pools, then we can connect into a 2 rows of them. 2 rows is there, one is rotating in this anti-clockwise direction, this is also rotating anti-clockwise direction. Through these rotating force, the The filament is moved in between these filament, and this is called mandrel. Mandrel is an heating coil like structure where filament is melted and it will stick in the form of layer by layer. This is the basic technology behind here, where the principle is where fusion deposition model works in the principle of melting and molding. Where melting in the sense we can melt the filament by using the heater mandrel, then we can stick by layer. This is the fusion deposition modeling. Most of the academic industries for study purpose, people they are preferred FDM for, because this is one of the basic 3D printing machine where people are easily learn the 3D printing by designing a simple designs, as well as the softwares. We doesn't require a specialized software. We are using that Tinkercad software. Using the Tinkercad software, we have the basic diagrams is available. Using that basic diagrams, we can print the basic components like scale or some other smileys. This is the fusion deposition modeling latest technology machine which was produced by MakerBoard. MakerBoard is one of the leading company. Those people can prepare all type of 3D printing machine for both academic as well as industry. So filaments, most of the filaments are thermoplastic material. So thermoplastic material, once we can the materials are once we heat it will come sticky. Once we leave the heat it will convert it into solid. That is the property of this material. So as I earlier said, ABS and polylactic acid, one of the best materials which we can use for in the form of filaments in this FDM. The price wise, this ABS and PLA is less compared to other materials, as well as they are biodegradable also. It won't affect the environment in the form of pollution. Then another important concept here is dual extruder. This is the single extruder where we can print only one color in the one side. If you want to have multiple colors, is also possible in FDM. We can connect two extruders in a single roller. Once we connect the two extruders in a single roller, we can get multiple colors. Okay, that is the only difference between single roller and dual. Then this is the FDM printed product, where this is the base place. Where base place we need to apply some paste like binders to set initially. Then afterwards it will works properly. There is no slight difference in that. After the process completed, we can easily pick the material. Then this is some of the commercial systems modeling available with the latest technology. With produces more limited colors. Okay, there is no limited colors is there. We can using this fusion deposition with multiple systems or multiple levels. It can approve. Then some of the companies where they can supply these machines: MakerBoard, Delta 3D printer, then Ultimaker, Cube from 3D systems. Then many other companies are available. The leading companies are MakerBoard is a leading company where we people are mainly use their printers for study purpose. The next one is stereolithography. Yes, sir. Stereolithography is a technology where the principle behind this is photoreactive. Okay, once we dip the material inside a liquid resin or liquid binder, then we can pass some heat via laser. It can stick. The same. The technology of 3D printing is same, where we need to heat the material and melt, then we can stick to it. Here we can dip that material into a resin, then we can do all the things. Here the same simple setup where we can prepare a huge pots through this stereolithography. That is the only difference here. Okay, there is a laser light which helps to cure the pots. Okay, this is I can show. This is the lattice points where we need to create a huge structure. People they are preferred stereolithography. A reservoir. This is a reservoir where it contains resin. We need to keep the substrate, that is raw material, into the resin. Then we need to pass the laser light into the reservoir. It will create the pots into it. This was developed the later 80s by Charles Hull. This is one of the successful 3D printing technology for massive structures, or successful 3D print technology for complex structures. We need to, if you want to produce a wheel or wheel hub, we want to produce a small car, or we want to produce a big machine, we can easily made all type of prototypes using serial lithography, because this serial lithography contains larger volumes. Okay, as a base of the plate, with the help of these larger volumes we can produce all the products. Okay. Then this serial lithography, where the resolution we are comparing to serial lithography and FDM. For smaller components, serial lithography is not at all suitable. For the larger components, serial lithography is one of the best choice for peoples or persons who are took for this technology, go to industry as well as for research purposes. The next one is digital light projector 3D printing. This is one of the advanced 3D printing technology, where we just simply with the photo here, that photopolymer is there. Photopolymers are polymer where it can cure using ultraviolet. Once we can pass that UV rays, it start good. But while comparing to SLS as well as our fusion deposition modeling, we need to provide more amount of heat for those materials, ABS as well as PLA. But this photopolymer doesn't require this amount of heat. Only we just apply a small amount of heat in the form of UV rays. This heat will melt the material and it will sticks together. This is the lens as well as you see this diagram, it easily understood. This what is that photopolymer, where we have placed that material. Once through this lens we just drive the light source, UV light source to the photopolymer, it will melt and it will converted into required parts. Then this laser mirror is replaced by means of projector, but projector is not at all advisable for this kind of drive through light to the another material. We people use mirror is very simpler than, as well as is very faster curing. There is no additional support for this SLE is required. It is a default process where we people are doing all the manufacturing systems which using this digital light projector. The main application of using this digital light projector, the DLP, is we can produce a small and very sculpture components with more books. If you want to print a doll, or if you want to print a sculpture with more amount of information, people they can prefer DLP, because the DLP is mainly focused or mainly used to produce a component by means of very small microns with high resolution output. The small microns with high resolution output, these components are very wisely very attractive for the business peoples with conventional material, well compared to conventional materials like wood, stone. This kind of output is very interesting to see in the form of output. Okay, then these are some of the crafts where you can see here. This is how small is there, but the work is very fine. Okay, the output of the work is very fine through this DLP 3D printing technology. Okay, the next one is photopolymer phase changing jet printers. So the photopolymer phase changing jet printers, where this is similar to our earlier methodology what we discussed with DLP. So where the difference is, we can produce some huge components using this technology. Okay, we can produce smaller components as well as very crafted products using DLP. But photopolymer, we can just in next level, we can print some large size components. For example, I want to print a pen, or I want to print a small pen with a camera, pen with a cap. So likewise, we can develop components using this photopolymer phase changing jet. Actually, this is a inkjet printer like technology, where the laser light is passed to and fro in the form of how the inkjet printer it works. Okay, this is the schematic diagram, where this is the inkjet laser hub, where we can have the laser hub produces a quantity of laser lights to the printed parts. Then Similar to SLA, photopolymers is also very good, but the technology is similar to our DLP, where we are using laser in the form of inkjet futures, where how the printer is rolls instead of inks, we can use the laser light process to supporting material, as well as while comparing to our DLP, we are going to produce some higher pots or some wisely bigger pots compared to that material. And also the materials also very different color materials we can easily produce using this photopolymer, because through this ink jet technology it is very easy for the manufacturer to add more number of colors in the base layer of the machine. This will place more number of colors in your mixtures. Okay. Then this photopolymer is commercially, this is a simple machine. One material, we can use more number of materials here. Okay, more than one material is very good supportive things for here. There's an advantages, as well as we can produce more amount of pixels also with a very good. This is some of the fabricated components I will discuss it earlier. We want to print a component with little bit higher microns, a little bit higher bigger while comparing to DLP products. Okay, the materials, these photopolymers are rubbery materials, so we can get a rubber-like structures using this technology. Also, some other 3D printing technology, we want to bring this rubber-like material which can easily flexible, but this technology is very much offered this kind of support for us to prepare a rubbery material as well as a product. Then multiple materials also used in a 3D printing technology, where this photopolymer we have multiple slots also there, in the which using this multiple slots we can add more number of colors, where the laser light pull the color into as a final product. The next technology is selective laser sintering, where it also called as directed metal laser sintering, DMLS also, where we can using powder or plastics, we can metal, ceramic, glass as a raw material. Okay, I hope you people understood. We can use the raw material in the form of powder, plastic undertone. Okay, the simple technology where the powder is rolled like this. Okay, once the piston is moved up the powder, where the powder is already compacted, when the laser light is passed on the powder, it converted into solid. Okay, that's how we can convert a liquid material into solid by means of heat. The phase change, same phase change is happened here. We can just combine the powder and we will pull the powder up, then we can pass the laser light on the powder. What happens finally, the compacted powdered component is converted into final part. Okay, this is simple technology behind here, where the power of the laser is little bit higher we required, because ceramics and metals are required more number of melting points. So based on the melting point, the more number of power is required to melt these materials, and also we need to build. The roller helps us to maintain the equal surface level of the material. Once the layer by layer formation, we need this much of pressure to make that material tightened. Once it will comes as output product. This relative laser sintering is one of the technology where people nowadays are using the piston manufacturing of cylinder in the automobile sectors using this technology. Then this is the process where I am explained in the earlier class, where we just simply we need to have a sintered pots, compacted pots, what else is metal, plastic or ceramics. Then we can pass the laser beam on the pot, it will stick together. Then finally we have the roller to keep all the particles in a complete flat form. So it's very easy to make this final. Then where this SLA, we can build metal-like structures and metal-like output using this SLA. This SLA is also one of the very good technology. This is the basics behind here, I mean principle behind here. First, the particles are like this. Once we apply some heat, it will join together. Then we can give some force, it will combine to the same technology. It will. This is the SEM image of the particle, how it bind together. Yeah, this is sinter powder means just the particle in the form of powder. That's the meaning for sinter powder. The particle in the form of powder which can less than 500 microns. Okay. Yeah, this is the SLS product machine. It was invented by Joe Bierman and Carl Deckard in the 80s. People, they will manufactured more number of machine parts using this SLS product. Then commercially it will sold by EBOS GMP. As well as we need, I already said we need a powerful laser for producing this component. This is the sample fabrication parts. We also make some machine parts also. You see this Airbus wing brackets, I have explained earlier. Very large or very huge machine parts also we can manufacturing through this laser, selective laser sintering process. Okay. Then plaster based 3D printing technology. This plaster based 3D printing technology where we can using multi-channel inkjet printed head, where we can see it will supported for very much of colored, mixed colored product. This plaster based because it doesn't require more amount of power through laser. Simple laser is enough, where we can got enough power to build this material into a product. Okay. Then this is similar process to SLS, where we have the colored product in a mixed colored in a piston. This piston moves up. Then we have a laser is passed on the surface of the material. Then we have the roller to make it compact. The only reason is where the materials which are required for the post processing is completely need for this kind of process, because the curing of material is completely different. I earlier said the melting point of material is high, so the temperature requires is also vary to material. While we are comparing different materials, the different material existing with different melting points. So these melting, based on the melting points, we need to supply the power of the laser, which helps to bind the materials together. Okay. Yeah. This is a simple laser machine, where the same that printing technology, this roller will move front and back and it will stick to it. Okay. This is a machine which was developed by MIT Alpha, okay, England, in the year 1995, where this is one of the academic technology which is developed in MIT, Manchester Institute of Technology, England. Then this plaster based 3D printing technology commercially available in different stages, as well as different properties. So this is one of the property, jet printer. So through this technology we can using fabricating toys. Most of the toys we can imported from China. Those toys are used in manufacturing through this technology. Here you can see the mixed colors. Okay, all the toys have mixed colors. So for this mixed coloring based polymer based products, industry people can prefer this technology to produce. This is one of the very sweet technology, where we can produce this kind of colorful images, as well as we can fabricated parts. It's also move under testing. Is also very simple. Then the material is also very rubbery material. It's not brittle. We can use some of the rubbery materials in thermoplastic polymers. It will good for production. The next one is thermal phase change inkjets, where thermal phase change inkjets are where we can fuse the inks, or we can have the material in the form of liquid. Then we can just using our inkjet printers, same, we can just simply push by inject from the bath for reservoir. These injected colors are filled here in the mandrel. Then the mandrel will have some heat and it will start printing all things. Okay, where we having some applying the wax in the base platform. While at the end of the process, it is easy to remove the process without damaging the substrate. So the excess material here, the only drawback is the excess material is that we can remove the excess material using some other machining operations, or what we people normally prefer. Okay. The reason behind this here, once we can having the excess material, because the curing is different, because the mandrel is a component which is required for curing of the plastics or this material available in the reservoir. So different materials have different melting point. So due to this, what happen means the excess material will come, the not cubed material will comes and settle down in the bottom side part of the product. Okay. So this is a thermal phase changing in sector, where this also working in the same principle, where we have the mandrel. The mandrel will supply some heat, the material will, the liquid material is converted into solid. Then the thermal phase, some of the best features is we have printed highly, extremely high resolution parts through this one. And as well as obviously the inkjet printers took more time. Same technology here they will follow, so the printing time is also very less. Then the materials is limited up to only plastics and wax. We won't use metal, ceramics or all other things here. As well as this manufactured object, it looks like a casted object. You people are hearing the casting, no, where we have the molten materials there. We can pour the molten that liquid material in the mold, then we will get the output of the product. Okay. Then this is a model of machine where this is thermal phase changing jet printers. Then this is some of the printer parts. You can see the craftsmanship. Okay, this is really, it looks very wonderful, like metal craftsmanship. Okay, we can build a smaller component as well as up to larger component. There is no size is different. Only we can consider the 3D printing technology. The base size and the base height is very, very important. The base high size and the base height is very, very important while we have to using this technology. Then laminated object manufacturing LOM. Laminated object manufacturing, where we have a material connected in a two level. We can have this level, a roller is there. It is passed through, a laser light is just we can pass here. It will melt it and it will stick. That's simple. Here we have the polymer. It will drive through a roller. The roller moves forward. This will also rotate. Then we can pass the laser light here. No, here there is a mirror which can divert the laser light directed to the center portion of the substrate. Then the substrate will stick to it. Okay. Then the platform is moves up and down for the next layers. This is a simple methodology, laminated object manufacturing, where through this technology we can, here that will explain clearly. Yeah, this is a roller, this is another roller which moves clockwise direction, where this is a driving force, where it can keep the material flatter surface. Then the laser is passed, driven through a mirror, then it will passes on the surface. This is the mold. This area is the mold where we are going to get the exact output or the part what we struck. The size of the part is applied here. Then the drawback is this is highly expensive. But the material cost is very less. The initial cost of setup is very high, but material cost is very low. Print resolution is very low compared to other products, where we can color can be ordered, but additional printers is required, but those printers is also costly. So paper is most commonly used here. The small components required support materials. We can printed use this LOM, but we won't go for the mass production using this LOM. While we require mass production, please we people are moved to SLS, DMLSLs as well as FD. Those things are looking for mass production, because there is no specialized machine is available to going for mass production. Okay. Now, this is a product where we can see from LOM. This is a supported material. Here once we can open this material, we get our parts. The excess material can be removed. Similarly, what we can see in the earlier DMLS, the excess material can be removed using this technology. Then commercially system helix, new cube technology, those people produces and commercially they will sell this machine. Then this is the printing machine, the exact schematic is here. Then some of the printed components. Okay. Yeah, thank you. I hope you people are having learned some of the basics about 3D printing technology. If you have any doubt, feel free to contact. Thank you.